The truck pulls away from the loading bay and moves toward the open road. The factory continues behind it, and pellets in a sealed drum is now on its way to store shelves around the world. At the loading dock, pallets are driven into waiting transport vehicles, each one carefully positioned to make efficient use of the drugs. When a product of this entire process are now secured and ready for the final stage of their journey to the consumer. With the quality release confirmed, the dispatch process begins. Pallets are retrieved from their storage locations and moved through the warehouse toward the loading dock, following the route prescribed by the warehouse management. With the review complete and every data point confirmed, the quality release is entered into the system. The batch status changes from amber to green. This single action authorized the dispatch of every pallet in the batch, the formal conclusion of the quality assurance process for this production run. Before any pallet can leave the warehouse, the batch it belongs to must receive a formal quality release. The quality manager reviews the complete digital batch record, every raw material test, every in-process check. On the warehouse management system's digital map, every pallet is represented as a data point. Its location, batch identity, this is the informational foundation that makes large-scale, high-speed warehousing both efficient and auditable. Automated guided vehicles move silently through the warehouse aisles, carrying pallets to their designated storage locations without human intervention. Navigating by floor-embedded pallet-embedded systems, they position. As each pallet enters the warehouse, its barcode is scanned at the entry point. The warehouse management system registers its arrival, assigns it a storage location, and begins tracking its status. From this point forward, the system knows exactly where this pallet is at all times. The finished goods warehouse holds the accumulated output of the production lines. Pallets stacked to height in perfectly organized rows, extending back. Every pallet represents millions of individual manufacturing decisions, all of them correct. A final pallet identification label is carrying the pallet's barcode track data. From this moment, this pallet is fully traceable in the warehouse management system, its location and status trackable at every point until it leaves the facility. The completed pallet is moved to the stretch wrapper, where it rotates slowly on a turntable while a film carriage travels up and down its height, applying multipartin in place for the rigors of transport. At the end of the production line, a 6-axis robotic palletizer takes over. With fluid summits, it lifts each sealed carton pattern. An automated labeling machine prints and applies the production label to every carton in a single seamless action. Batch number, manufacturing date, product information needed to trace this carton back through the production process is now permanently and precisely recorded on its surface. Each filled carton moves immediately to the case sealing station, where the top flaps are glued and folded closed in a continuous automatic motion. Carton arrives open, squarely secure. It is now a complete unit of secondary packaging ready for labeling. The bars slide into their carton in a single, smooth automated sequence. Each one is positioned with front to back, row by row, until it holds exactly the right quantity and configuration. Individual wrapped bars are now grouped and counted by the cartoning system. Precise quantities are accumulated and loaded into open cardboard cartons by the cartoning machine, each card receiving an exact within the pack. Wrapped bars flow continuously from the machine, each one a complete finished unit, individually sealed and ready for retail. The transformation from raw material to consumer product is now, for each individual bar, entirely complete. The final flaps fold down and the heat seal element presses them close, firm contact. In less than a second, every seal is firm. The bar inside is fully protected and its appearance on a retail shelf will be impeccable. In slow motion, the wrapping sequence reveals its elegant precision. The bar is placed onto the packaging sheet. The long sides fold inward. The end flaps begin their shakes of time, perfectly repeatable choreography. The packaging material carries the product's complete printed design, applied by high-speed printing presses. Before this roll was evident that every wrapped bar carries a perfectly aligned, professionally finished appearance. The wrapping line operates at remarkable speed. Pre-printed packaging material unwinds from large rolls at one side of the machine and fully wraps emerge from the other, with the wrapping machine completing every fold, crease, and seal automatically in between. Each cooled bar moves seamlessly from the cooling tunnel toward the wrapping line. Its surface is matte and firm, its edges are clean, embossed pattern is sharp. This bar is, in every measurable sense, a finished product, needing only its packaging to complete the journey. Bars exit the cooling tunnel firm, cool, and dimensionally stable. The embossed pattern that was pressed into each bar at the stampings finds their physical form, ready for the last major stage of the production process. Inside the tunnel, cool filtered air flows continuously over and around each bar as it travels forward on the conveyor. The controlled air thermal stress that could cause surface cracking in a less carefully managed cooling process. Before wrapping, every stamped bar must be properly cooled and conditioned. The cooling tunnel, a long enclosed conveyor, receives the warm bars at one end and delivers them firm, stable, and dimensionally set at the other. Statistical process control charts display the performance of the production line in real time. Every data point from the checkware and vision system feeds into these and trend charts, allowing any drift in quality before it becomes a problem, and to act before a single non-conforming bar reaches the consumer. In the quality laboratory, dimensional checks are performed with calibrated instruments. Length, width, effectiveness of a millimeter. Every measurement is logged and compared against the specification, building a complete data record for every production batch. Alongside the automated systems, human quality inspectors provide an additional layer of assessment. Bars are periodically removed from the line for detailed embossed sharpness, edge definition, and fragrance character against the reference standard. The vision system's artificial intelligence analyzes each image in real time, scanning for cracks, surface blemishes, incomplete stamping, discoloration, or any other irregularity. The entire analysis takes less than 1/10 of a second per bar. Beyond the checkware, every bar passes through a camera-based vision inspection tunnel. High-resolution cameras capture images from 4 directions simultaneously, giving the inspection algorithm a complete 3-dimensional view of every surface. When a bar falls outside the weight tolerance, the checkweighers reject system acts in milliseconds. A diverter in the bar is required to stream the bar from the quantity of accepted bars. The checkweigher evaluates every single bar. In a fraction of a second, the bar's weight is measured and compared against the specification range. A green light confirms acceptance. The bar continues forward. Every bar that leaves the stamping press must pass through the quality inspection zone before it can proceed to packaging. This is a layered system, multiple technologies working simultaneously to evaluate each bar against the full set of quality specifications. The small amount of soap trimmed from each bar during stamping does not go to waste. It is collected beneath the press and returned automatically to the production tool and is reprocessed in the pack into the soap mass. Efficiency in this facility is absolute. Bar after bar exits the stamping press in a continuous, uniform stream. Each one is identical to the last. Same shape, same dimension or perfection, repeated hundreds of times every minute. The freshly stamped bar is a study in precision. Every edge is sharp and defined, every face is smooth and consistent. The embossed pattern stands in crisp relief, a reproduction of the die design, pressed permanently into the soap surface with every stroke of the press. In slow motion, the full stamping cycle is revealed. The upper die descends with force. The cells are closed completely irregularly, except the simply detail of the direction. Each billet is positioned precisely within the lower half of the die. Seat exactness in the fallacy here is of the course of the pitching, any deviation in an off-center bar, or an incomplete stamp. The stamping press area is where the soap billet becomes a soap bar. A row of high-speed stamping presses operates in simulating billions of compressive force through precision machine dies and producing a perfectly shaped embossed bar in a single stroke. Before stamping, the billets pass through a brief cooling zone. Directed airflow brings their surface temperature down slightly, firming them just enough for the stamping press to work with maximum precision. Freshly cut soap billets travel away from the cutter in a steady single-file stream. Each one is correctly sized and correctly weighted to use them by the die cross-section to press a time and cut. In slow motion, the elegance of the wire cut is fully visible. The wire descends cleanly through the log in a fraction of a second, leaving behind a cut surface that is perfectly flat and smooth. No crushing, no tearing, just a precise, clean separation. Positioned directly downstream of the plotter, the wire cutting machine operates in perfect synchronization with the extrusion speed, a thin, tumbling wire, dividing the continuous log into individual bars of consistent, controlled length. The soap log moves steadily along the discharge for fair is sacked. Every centimeter that emerges from the die is identical to the last. It now needs only one thing, to be cut into individual bars. At the die plate, a precision machined opening at the exit end of the second stage, the soap log makes its first appearance. It emerges if it is a Campusine crust smooths across sections. At the perforated plate between the two stages, the compacted soap is broken in powdered start. Immediately, every trace of air is removed and the density of the material is maximized. In the first stage, a powerful rotating screw draws the soap mass into the barrel and works it forward under pressure. Any residual air pockets still present in the material are progressively compacted and driven toward the perforated plate that separates the two stages. The refined soap mass now enters one of the most defining machines in the entire production line, the duplex plotter. This two-stage industrial extruder will take the processed soap mass and form it into something recognizable, a continuous, perfectly shaped soap log. Some modern facilities use continuous refining extruders in place of roll mills. The principle is different. A precision screw works the soap under controlled temperature and promises the smooth, ready for the plotter. The refined soap sheet peels cleanly from the final roll, smooth, plastic, and perfectly uniform in texture. The difference from the material that entered the refiner is immediately visible. This is the quality that precision engineering. The soap mass passes through the narrow gap between each pair of rolls under intense pressure. Any remaining particle, undispersed additive, or textural inconsistency is broken down to the net. With each pass, the material becomes measurably smoother and more uniform. From the amalgamator, the blended soap mass enters the refiner. This powerful machine, equipped with a series of precision ground hardened steel rolls, will take the amalgamated material and work it into a state of perfect smoothness and homogeneity. Inside the amalgamator, the mixing action is powerful and thorough. The machine works the noodles and additives together with continuous mechanical force, breaking down the noodle structure evenly throughout the entire mass. Consistency at this stage guarantees consistency in every finished bar. Perfume concentrate is dosed with pinpoint accuracy by a metered pump system, ensuring that every bar produced from this batch will carry exactly the right fragrance intensity, consistent from the first bar to the last. Soap noodles pour continuously into the amalgamator's feed hopper, measured precisely according to the batch formula. The machine receives them steadily, ready to incorporate the additives that have been weighed and staged according to the day's production schedule. The amalgamation stage is where the soap noodles become a true beauty product. Into the amalgamator go the noodle L with a large effect on the final soap and brightening compounds. Before the noodles proceed further, their moisture content is verified by an inline analyzer. Every batch must meet the precise moisture specification, because the water content of the noodles directly affects the performance and quality of the finished bar. The noodles are immediately conveyed away from the drying tower on a clean stainless steel belt. Moving at a controlled pace, they travel toward the next stage of processing, where their transformation from basic soap base into a fully formulated beauty product will begin. At the base of the tower, a continuous flow of soap noodles accumulates, small, white, irregular pellets that are dried in structure. These noodles are the base material for everything that follows. From liquid soap to solid noodle, the transformation is complete. As the droplets fall through the tower, a carefully directed stream of hot air meets them. The combination of heat and reduced atmospheric pressure causes moisture to evaporate almost instantly from each droplet's surface. At the very top of the tower, the liquid soap is forced through precision atomizing nozzles. In an instant, the liquid stream breaks into many droplets, each one a microsphere of soap solution, and begins its controlled descent through the tower's interior. The washed soap mass still carries a substantial amount of water, far too much for a finished bar product. To remove it, the soap is sent to one of the factory's most impressive pieces of equipment, rising through multiple floors of the building. Purified glycerin accumulates in dedicated storage tanks, carefully metered and logged. This recovered byproduct represents both economic value and the facility's every kilogram of raw material that enters the process. The spent lye is not discarded. It is directed to the glycerin recovery unit, where further processing extracts and purifies the glycerin, a valuable material used widely in cosmetics and pharmaceutical products. Nothing produced in this facility goes to waste. Inside the settling column, the separation is clear and distinct. Above the interface line, the purified soap phase forms a dense, creamy layer. The boundary between them is sharp, a visible line between raw material and refined product. Concentrated brine, a solution of salt and water, is introduced into the soap mass. The salt causes the soap molecule while the glycerin, salts, and dissolved impurities settle downward into what is known as the spent lye. The neat soap now enters the washing and separation stage. A series of tall settling vessels stands ready, each one a stage in the progressive remunification of a subsetting of the valuable products. Emerging from the reactor is neat soap, the direct product of saponification. It is thick, pale, and paste-like at this stage, carrying within it not just soap molecules, but also water, glycerin, residual salts, and impurities that must now be carefully removed. Unlike traditional batch soap making, this is a continuous process. Raw materials enter one end of the reactor in a constant, controlled stream, and neat soap exits the other end without interruption. The line never stops. The chemistry never pauses. Through the inspection glass, the transformation is visible. The clear oil and lye streams enter and almost immediately begin to change, thickening, turning opaque, taking on the creamy consistency of soap. Outside the reactor, instruments track every parameter of the reaction taking place within. Temperature, pressure, and flow rate. Our reactor's outer shell is warm to the touch, evidence of the exothermic chemistry occurring inside. At the reactor inlet, the two streams meet. The oil blend enters through one port, the lye solution enters through another. Kept separate until this precise moment, their meeting after initiates the saponification reaction, and the transformation into soap begins. The prepared lye solution, now at its precise working temperature, flows through dedicated pipework toward the reactor. Every aspect of its concentration and temperature has been verified before it is allowed to proceed to the point of reaction. First, the sodium hydroxide must be prepared as a precise aqueous solution. Solid pellets are carefully dosed into demineralized water in a dedicated general vessel, which the vessel's cooling system immediately brings under control. The saponification area is the chemical heart of the entire factory. Here inside a purpose-built soap making for various soap makes of years takes place, controlled today with a precision that earlier generations could never have imagined. When the blend is complete and confirmed, it moves by pipeline to the saponification unit. The warm, unified oil mixture flows steadily through insulated lines, approaching the stage where its fundamental chemistry will be permanently transformed. From the central control room, operators monitor every variable across the entire blending system. Data flows in continuously from dozens of sensors: temperature, flow rate, pressure, process level. Throughout blending, sensors monitor temperature, viscosity, and fill level in real time. Each parameter must fall within a defined target range, because the chemical reaction that follows is sensitive to even small variations in the condition of the oil blend. The vessel's internal agitator rotates continuously, keeping all oils in constant, even motion. No single oil is allowed to separate or stratify, be perfectly uniform before it can proceed to the next stage of the process. Inside the vessel, the oils meet for the first time. Palm oil brings hardness and stable lather. Coconut oil delivers rich, abundant foam. Palm kernel oil adds to together they formness and cleansing of the soap. The blending formula is programmed into the process control system. One by one, automated valves open in sequence, releasing precise, pre-calculated quantities of each oil from their individual holding tanks and directing them into the blending vessel below. With raw materials stored and verified, the first active production stage begins: oil blending. At the heart of this area stands a large temperature-controlled pistol blend to bispistol required for today's production formula. Every container is logged into the facility's material management system the moment it arrives. Batch numbers, arrival dates, and test results are all linked digitally, creating a complete chain of traceability from this point forward. Fragrance compounds arrive in sealed, temperature-protected drums. These complex blends of aromatic chemicals will ultimately give each soap bar its distinctive scent, a carefully engineered sensory signature developed to exacting standards. Due to its highly reactive nature, sodium hydroxide is stored in a completely dedicated zone, physically separated from all other materials. Emergency safety equipment is installed throughout the area, and only trained, fully protected personnel handle this substance. Alongside the oils, a second critical ingredient enters the facility: sodium hydroxide, commonly known as lye. This highly alkaline compound, arriving as solid white pellets, is the chemical agent that will react with the oils to create soap itself. itself. Every transfer through this facility is controlled by automated valve systems, at the command of the process control software of open and close with precision, measuring and directing each material exactly where it needs to go, at exactly the right time. Approved oils are transferred directly into temperature-controlled holding tanks through insulated pipelines. Each tank is sealed, monitored, and precisely managed, maintaining the oils in perfect condition until they are needed on the production line. Analytical instruments process each sample with extraordinary precision. Every data point, every percentage, every measurement is recorded and compared against the specification. There is no room for approximation at this stage. In the on-site laboratory, each oil sample undergoes a full battery of tests. Technicians check the fatty acid profile, moisture content, free fatty acid levels, and screen for any trace of contamination. Only materials that pass every test are cleared for use. Before a single drop is accepted, samples are drawn directly from the tanker. The quality control team collects precise volumes of oil for immediate laboratory analysis, because nothing enters this facility without verification. The journey of every soap bar begins here, at the raw material receiving bay. A large tanker truck arrives carrying tons of carefully temperature-maintained vegetable oil, the first and most essential ingredient in the entire process. Inside, the production hall stretches far in every direction. Automated conveyor lines run per upon. Stainless steel shop. This is a world-class manufacturing environment operating at full industrial scale. Every day, long before the world wakes up, this facility is already running. A modern beauty soap factory, where science, precision, and scale come together to produce millions of bars that will reach hands across the globe.